Let's take a closer look at the Ariel Hipercar today. The car company Ariel is today famous for their lightweight Ariel Atom, which started as a student project at Coventry University, where today's boss Simon Saunders was senior lecturer for transport design. The first prototype was shown in 1996, and despite only having 135mm wide tires, the car was very popular and was the basis for the company's success until today. In recent years, the UK started an innovation program called Innovate UK. It provides funding for mobility projects with future technology. Ariel's latest hypercar is one of the results of this program, which provided £2 million at the beginning of this project and will provide another £6 million until the production starts. To put these numbers into perspective, keep in mind that designing the Porsche Panamera from scratch costed Porsche €1 billion. And the 2013 Mercedes E-Class facelift costed Mercedes €1 billion as well. Ariel is a very small company, and designing a new car is a big thing for them. Even more so because it's their first electric car. So let's take a closer look at how they did that. The chassis consists of an aluminium monocoque which is bonded and riveted together. For the roll structure they created a separate frame, which includes the windscreen frame, rear roll structure and a center bridge. Because of that layout, the seat belts are fixed in the center. They then use a large 800-volt battery underneath and between the seats with 62 kWh. We can see the connectors to charge the battery on the left-hand side. Special about the hypercar is the high seating position because you are sitting on top of the battery. Sports cars usually have a cutout for the seats and the battery or are U-shaped, but this is creating extra cost and complexity in the battery design. So Ariel went for the more straightforward way, designing a huge battery block and accepted the high package. We can see that the roll structure is actually lower than the headrest of the seats. Ariel then used aluminium profiles at front and rear for the subframes. The car has double wishbone suspension all around, and very nice is that Ariel shows us the car without bodywork. They use 4 electric motors, so one for each wheel without mechanical connection to each other, which gives them a great basis for torque vectoring. Each one of them has 220 kW, so 295 horsepower and 450 Nm. That allows the car to accelerate from 0 to 60 miles per hour in 2 seconds, and from 0 to 100 miles per hour in 4.4 seconds. Very interesting here is the cooling. If we look at the naked car, we can see 6 expansion bottles, 4 at the front and 2 at the rear. That means there are 6 cooling circuits. Why would they do that? Thermal management is very important for electric cars, and if you want to know more about this, check out my other video in the description. If I have multiple components like electric motors, coolers and heaters, I could join them all together to a complex cooling system with multiple valves. Or I can create a few separate cooling systems, which is a much simpler way. Such a cooling system consists of an electric motor, a pump, a radiator, and an expansion bottle. Since we have 4 electric motors, we have 4 of these small and simple cooling circuits. The size of the expansion bottle depends on the overall coolant volume of this circuit. We can see 4 expansion bottles with the same size, 2 at the front, 2 at the rear. So these must be for the electric motors. In an earlier rear-wheel drive version of the car, we could see that the front side radiators were gone, which means they must be for the front motors. But what are these other 2 cooling circuits for? There's a small expansion bottle and a large one. The small one is for the interior climatization. With Ariel not being experienced with air conditioning systems, they use known components like a high voltage heater. Water is flowing through this one and is then guided to the dashboard where it's heating the cabin air. So that's a very small circuit. The large expansion bottle must be for the battery cooling. We can see a large radiator in the front center and 2 additional radiators at the back, which could also help with battery cooling. For the AC system, we can see an electric climate compressor that is rigidly connected to the chassis, which will create some amount of body noise. You would usually mount them with rubber bushings to avoid unwanted noise. And then, at the very front, we can see 2 components that are called chiller and icont. Both are heat exchangers between refrigerant and water. So the icon is a water-cooled condensator, so it's heating up the water circuit. The chiller is a component to cool the water circuit. If we look at the standard AC system, we have a compressor which is sucking refrigerant gas and compressing it to higher pressure. It then flows through the condensator where it's cooled down and becomes liquid. Then it runs through the expansion valve. Because of the sudden expansion, the refrigerant is cooled down a lot and runs through the evaporator, which is basically the radiator in the dashboard that cools down the cabin air. So, since we cannot see an air condensator at the front anymore, unlike older versions, and because we can see an expansion valve close to it, this could be a water-cooled condensator, and the component next to it, a chiller. Also, we can see a BMW expansion bottle for what's usually hydraulic power steering. Again, a new topic for Ariel. Interesting here is also that the steering sits behind the front axle, but the brake calipers are behind it too. Usually you locate them opposite of each other to have enough space. So let's have a look at aerodynamics now. We can see that the package is pretty slim and high at the front, and that is what we can see in the design again. The carbon fiber bodywork wraps around the center and leaves lots of space at the sides for the air to flow. Of course, the air has to reach the front radiators, but can then flow along the inner sides of the front wheels and out along the sides. Behind the door we can see an air intake either side for the rear radiators, and from the back we can see that the last two radiators got a lot bigger than on the prototype. Also, at the back we can see a short and very steep diffuser and a turbine exit on top. This optional Cosworth turbine with 35 kW will act as a range extender and currently runs on fuel but could be used with hydrogen in the future. The inlet for the turbine is at the top and merges into a large shark fin. The vertical elements of the body should improve stability and the front ones should shadow the side mirrors, but it would be interesting to know for which yaw angles. So all in all, the Ariel Hypercar is a unique result of the British Innovation Programme and the first closed and electric car from the small manufacturer Ariel. It helps them to build experience with electric drivetrains, which will help them in future projects. See you at the next video.